Hi everybody, welcome to my channel again. This is Oliver. We are learning algebra by working through problems from the Larson textbook. Today we're doing section 1.6, which is to represent functions as rules and tables. So let's start. So today we're going to do practice A. So first problem, actually first let's cover some of the main concepts of section 1.6, and that's domain, range, and function. A domain is a collection of inputs. So as you can see here on my screen, the inputs here 1, 2, 3, 5, 7 on the left here. So a collection of inputs, that's called domain. A collection of outputs is called range. And then we have a function, something like y equals 2x, something like that, 2x, I don't know, plus 3. This is a function where you have an input variable and an output variable. And then for each input, you have exactly one output. And that's the main key, one output for one input. Okay. So let's start. The first problem, the collection of all output variables is called the range. So that's the range that we just covered that. So number one would be range. Number two, the collection of all input variables is called the domain of a function. Okay, identify the domain and range. As I said, domain is a collection of all the input. So domain, and let's represent domain as D. So it's 1, 3, 5, and 7. 1, 3, 5, 7. Range, or R as a shortcut, is a collection of all the output. All the outputs. So it's 8, 7, 6, and 5. For number 4, the domain is 7, 2, 5, and 3. The range is 4, 2, 1, and 5. So these are pretty simple. Okay, this is the section 1.6. This is practice A. So the domain for number 5 is 0.4, 0.5, 0.6, 0.7. The range is 15, 13, 11, and 9. Number 6, tell whether the pairing is a function. And again, function is when you, for each input, you have exactly one output. So one input, one output, one input, one output, one input, one output, one input, one output. So yes, it is a function. 7, 6, one input, one output. But here we have two inputs, right? For the same input, you have two different outputs. So this is not a function. So no, this is not a function, because for each input, we have to get one output. But for this for the input 3, we get two outputs, 1 and 4. So this is not a function. Okay. Number 8, 10, 11, 12, 13. So all different inputs. Okay. So this is, yes, this is a function, because for each input we get an output. Next, number 9, make a table for the function. Identify the range of the function. So if you get a table, we have the domain and we have the range. So the domain will be 0, 1, 2, and 3. So let me actually zoom in some more. So identify the range. So if x is basically the domain. So if x is 0, 4 times 0 is 0. So y is the range, right? So if x is 0, 4 times 0 is 0. So y is 0. So the for the input 0, the output is 0. For 1, we get 4 times 1 is 4. So y is 4. Then for 2, we get 4 times 2 is 8. For 3, we get 4 times 3 is 12. So what's the range? The range is 0, 4, 8, and 12. Okay, so you can say range, or R. 0, 4, 8, 12. Okay. Number 10, y equals x plus 2. The domain is given to us. So let's draw a table again. And we have 1, 2, 3, 4. So 1, 2, 3, 4. And we have the domain values 11, 15, 22, and 27. The function is y equals x plus 2. When x is 11, 11 plus 2 is 13. Then when x is 15, 15 plus 2 is 17. When x is 22, 22 plus 2 is 24. 27 plus 2 is 29. So what's the range? The range is 13, 17, 24, and 29. Number 11, the function is y equals x minus 3. Let's do the table here again. 1, 2, 3, 4. So we have 5, 9, 14, and 19. The function is y equals x minus 3. 5 minus 3 is 2. 9 minus 3 is 6. 14 minus 3 is 11. 19 minus 3 is 16. So the range is 2, 6, 11, and 16. And number 12, flower garden. You have a flat of 12 plants that you're planting in a garden. Under A, copy and complete. Each time you put one plant in the garden, you have one less plant in the flat. Okay, so question mark is a function of question mark. So this can be represented as a function y is 12 is what you have, minus is what you plant. So this is the number of plants planted. And then this is number of plants left. Okay, so if you plant one plant, 12 minus 1 is 11. 11 is what you have left. So the number of plants left, so this goes here, is a function of the number of plants planted. This goes here. Okay, write a rule for the number of plants y you have left in the flat as a function of the number of plants x you have put in the garden so far. So this is that function. Make a table and identify the range of the function. Okay, so this is going to be a pretty long table. Why? Because we have 12 plants, so it has the domain is from 0 to 12, right? So 1, 2, 3, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so if it's 0, if 0 plants you plant, 12 minus 0 is 12. 12 is what you have left. All the plants are left, right? And then it goes, it increments by 1. So 12 minus 1 is 11. So this decreases by 1. So when it's 2, this is 10, 3, it's 9. And the sum of these two is 12, right? So 4 plus what is 12? 8. 7, 6, 5, 4, 3, 2, 1, and 0. Identify the range of the function. So the range would be 12, 11, 10, and all the way to 1, 0. Okay, this is the range right there. Number 13, centerpieces. A florist is making centerpieces for a charity event. She's using 9 flowers in each centerpiece. Write a rule for the total number of flowers used as a function of the number of centerpieces created. So 9x or y equals 9x. So that was number 13. Y equals 9x is the function. Number 14, kickboxing. You join a kickboxing class at a local gym. The cost is $5 per class, plus $25 for initial membership fee. Write a rule for the total cost of the class in dollars as a function of the number of classes you attend. So it would be y equals the fixed fee of $25, so 25, and then depending on how many classes you attend, so $5 per class, so 5 times x. X is the number of classes you attend. So that's the function. How much will it cost if you go to 8 classes? So y would be 25 plus 5 times 8, or y equals 25 plus 5 times 8 is 40. So it would be $65. Okay, so that's all for today. If you'd like to see more videos, please like and subscribe to the channel. Thank you so much. See you next time. Bye-bye.